All right, so those are the updates from our end, and I think it's a good time to transition to the education session. So we have Richard, and we also have today uh, David Johnson. So I'll pretty much stop sharing now and let them control the screen and take the presentation. So yeah, feel free to start with your introduction and maybe take over the session. Thank you.
Alrighty, so thank you guys for allowing us to share to the Meta Standards Forum. I was originally pointed towards you guys by a friend and colleague of mine, Josh Perry. He follows the forum, and he thought that it would be a really awesome avenue to kind of to share what we've been doing. So my name is David Johnson. I'm an industrial designer located in the Pacific Northwest. I graduated from SCAD like 13 years ago. And since then, I've been working for a myriad of product development companies. My current focus is on go-to-market strategies for small businesses. With me is Richard Colburn. He is a software engineer with 15 years under his belt and a very, very, very smart guy. And yeah, and so we are basically diving into a software platform that he has been developing. And we got together because I saw his software and I saw an opportunity to cater it towards um, being able to construct garments and then also animate and render them in real time very quickly. And so we kind of set off on that endeavor, and we're here to kind of show you where we are at this point and what this might be able to do for other designers in the space. I guess I should have asked if you can hear it. So this first bit, it jumped into the video before I could explain it very quickly. So actually, let's go back. So this is the second. All right. So this video shows what his software can do instead of keyframing or using other methods. This uses pose target physics and it influence targets, and then it uses a collision system. Now, Richard is a pro as the expert on this. Do you want to talk a little bit about what this software really does?
Yeah, it might not show up very well in the video because it's a little bit of a lag, but I spent a lot of years creating animation assets for both serious simulation and video games, and the hard part of doing animation and making it look realistic was always getting all the subtle movements. And so when I was creating vehicles, I would just, set up a vehicle with a whole bunch of physics and then drive it like I was playing a video game. And for years I thought, why don't they do this with characters? So I finally had the opportunity here. It took me about 8 months of full-time work to set up a system that's basically a physics engine for character rigs. And as I was working with it, it occurred to me there's basically three major components to it. One is just having the pose target. So it's sort of like a guide. I want my character to be in this pose and then in this other pose. And then the physics itself will drive the character towards the target poses, taking velocity and air drag and collisions with objects and gravity and all these physics concepts into consideration so that the motion ends up looking a lot more realistic. And then I found that sometimes you need to override the physics to some extent. For things like a character would tend to just fall over unless you have some way of stabilizing it. So the influence targets do that. It allows you to sort of override what would naturally happen with the physics. And then with the collision system, you can set the friction and collision margins and things around the different parts of the character rig. So working with those three concepts as I was developing it gave me basically the best results. So, and the video is sort of a demo of these three ideas. So if you want to show the video.
Absolutely. Let me know if you can hear the sound this time.
Character physics is a new way of thinking about how to
Yes.
do animation, using three basic concepts. First, it uses a standard character rig with an identical pose target. Instead of posing your character, you pose the target, then let the physics engine move your character towards the target poses. This automatically adds realism to your animation. Second, you can directly interact with the physics using influence targets. This way you can let the character physics engine add realism to your character's motion but you still get precise control of how your character moves. Third, using the collision system, your characters can interact with the environment.
Awesome. Alrighty, let's move on to the next slide here. So, I'm just going to read off the side here. This video illustrates that these tools are not just for animating avatars. They are extremely powerful in animating all categories of movement. I should jump in and mention at this point that the reason that Rich and I got involved with each other is that I design clothing. And I have been, I design patterns, I'm doing tech packs, things like that. And but I come from a background in product development. I'm a 12-year vet of SolidWorks, Inventor Pro, Rhino, things like that. And that's what I'm used to building in. And so we got to having this conversation about what his software can do. And I was like, man, wouldn't it be cool to be able to design clothes the way that I design, hard goods, and then find a way to very quickly visualize them. And he was basically like, I already am doing that, but let's kind of fine tune it a little bit. And that's sort of where we got to now. But I'm going to play this video.
Character physics is a physics engine that works with armatures. It allows you to create lifelike movements with very little effort, similar to what you would get with motion capture, but without the need for motion capture equipment. With this new animation paradigm, you can save countless hours of work and achieve far better results than you would with typical posing and keyframing. You can easily customize the physics settings of each part of your character so the mass and muscle strength matches your character. This opens the door for realistic motion that would have been impossible with motion capture, simply because you can't put motion capture equipment on characters that don't exist in the real world. Character physics is also useful for working with existing motion capture data. For example, you can add physics effects to an existing character. You can easily do things that were never before possible with existing motion capture data. For example, making this sword appear much heavier. Motion capture data can also interact with collision objects. Notice how the tip of the sword hits the ground and drags. You can easily clean up or adjust motion capture data by using physics interpolation or mixing the influence of the motion capture data with the physics. This lets you correct issues like outliers, IK popping, or even change how your motion capture data interacts with the virtual environment. With very little effort, you can create a simple walk cycle that turns into a smooth, organic-looking walk cycle with subtle, nuanced movements. The character can also interact with physics objects while walking. Physics armatures are fully customizable, so you can also easily animate things like ropes, wires, chains, or whatever else you can imagine. Now keep in mind this is in active development, so there should be new features and improvements on a regular basis.
Alrighty. Moving on. Whoop, nope. There we go. All right. So, and then that sort of summarized, this summarizes what was just mentioned. The key difference between what we're doing and how animation is currently being done is that instead of keyframing, we're letting physics handle a majority of the movement, which gives us motion capture quality movement with minimal effort. So a new workflow. So now Rich and I have sort of set off because my background again is in CAD development. I'm familiar with tools like Illustrator, vector-based work and stuff like that, and that's what I'm used to designing tech packs in. And so I'm working with him to try and find a way to integrate his Blender Ready software and the way that people in my profession or other clothing designers, fashion designers might want to interact with this kind of software. Awesome.
So just for clarification, kind of the feature or the real achievement there is that you click on the garment once you've created the garment, and there's all the tools for generating the patterns and generating the topology from the patterns and easily defining sewing relationships. But then once the garment has been fitted to the avatar, with a single click, it will copy all of the armature data that's in the character so that whatever animations are happening in the character's armature, they will match the clothing with a single click, because it basically measures the distance to the body, pulls all the vertex weight data that would assign the character mesh to the armature, and copies and blends all that data to exactly match. So there was no weight painting or vertex weight adjustment or anything. It's perfectly grabbing all that data off the character mesh.
Awesome. All right. So, oops, no, I keep doing that. Alrighty, so why this matters. Proprietary versions of software like this, they do exist, but they're closely guarded by companies like Blizzard or Activision. But this software that Rich has produced is Blender ready. It's open source and it's available online since Wednesday of last week for anyone that goes looking for it. We believe that these tools can dramatically simplify the way or change the way that animation is done. And so that is our presentation. Rich is an absolute expert in this subject matter. I'm sort of here to help, just talk to him and kick doors open and stuff like that. So, do we want to ask questions or talk a little bit more about it? I'm happy to stop sharing my screen.
Yeah, this is amazing. Yeah, thank you for sharing the work you guys have been doing. Definitely, it's kind of seeing Marvelous Designer, but the features of that, inside Blender. And I can already imagine the contour, because our team was working on making some apparels, and they have to calculate all the scale differences across those tools, and it was causing a lot of round trips. I think this is definitely a big win if the same pattern making can be done inside Blender and then mapped it. Amazing. Yeah, just a quick question, and then we'll open the discussion for the entire room as well. The armature that you mentioned, I think you guys were using Mixamo, right, when you were showing the physics-based animations?
Yeah.
Does this, yeah.
What was your question?
Yeah, so I was just wondering, does the system support any kind of skeleton, like let's say Rigify or any custom skeletons?
So when you have a skeleton that's set up for motion capture or something, there's usually custom bones in there that are just for deforming. There's bones that have drivers on them for when the knee bends and these kinds of things. So a rig for deforming a character, it's not like a single click and we run physics on all of that. The workflow is you build a more simple skeleton that doesn't have all of the extra control bones and things. That would be more like the actual bones in a human skeleton, and you let the physics drive that, and then you constrain your existing rig to the physics rig. So if you're building a rig from scratch to work with character physics, then that workflow makes it really easy. But if you're trying to adapt some really complicated rig with all kinds of control bones and constraints and things, it's better to just build a simple physics rig that matches it, and then you sort of parent the critical bones to the physics rig. And there's actually a whole tool set that I had to put in there because I realized that was part of the workflow that allows you to select this bone over here and select this bone and automatically copy all of the bone roll data and the positions and things and generate the constraints automatically to make it easier to do that setup process. So.
Right. Okay. And in this case, once that, I guess once the desired animation is created, then we just bake it and export it. It can be exported for runtime engines, right?
Yeah. So there's a record option built into the character physics thing. once you like the way your animation is done and you've got your influence targets, maybe they're animated to move around, or maybe the strength of their effect is animated so that the character kind of falls over and then stands back up again, or whatever you want to do. The final result, you just hit the record button and it keyframes the position of every bone, so you can export it as an FBX or whatever IGS.
Yeah, got it. Good stuff. So yeah, so I'll if anybody else have questions, please go forward. And meanwhile, since you mentioned the product is already launched, can you share any links and also kind of getting started guide? I'm just curious to see like what would it take to, let's say, like installing your plugin to all the way to create maybe a simple walk cycle or a simple idle cycle, right? Just using physics. Um, can that be done without any additional keyframing? And can that also create varying results of walk cycle, right? Like for example, a zombie will walk differently versus a human will walk differently, right? So how do we factor in those changes?
Yeah, for like I showed the one character who was walking along. It was like a Roblox character. It's literally like just a repeating the feet lift up and move forward, and that happens on the pose target. It's just happening in place, and then you let the physics and the friction and the stabilizer just kind of hold things, and the feet hit the ground and they move the thing forward, and it just walks. And then you can use you just rotate the stabilizer so that the character kind of turns and changes directions, and the feet actually will just kind of move correctly and spin around. And it works great on bipeds and spiders and insects and all that kind of stuff. So
Makes sense.
but what you would do, for a zombie, you would, you could add some randomness to the way that the zombie moves. But you would still have basically just the legs just doing kind of a repeated motion like this. And then you set it on a ground plane that you set as collision and put a rotation stabilizer there, and you just sort of let it walk along. And then I don't know if you would maybe put some noise on an influence target so the zombie kind of moves like it's jerking around or something like that.
Could you even increase friction? Like if you had to increase friction on one leg to simulate more of like a dragging, the way that you dragged the sword, on the ground, things like that.
Yeah, you could certainly do that.
Okay.
There's all kinds of, sky's the limit as far as like adjusting things and tweaking things and messing with it. It's kind of addictive, actually.
And so you do have all the links to everything. Are you seeing the chat over here?
Yeah, I'll go ahead and dig up those links real quick and drop them in the chat.
Awesome.
Yeah, and meanwhile, yeah, Hideaki, Joe, Katie, if you guys have questions,
Yeah,
go for it.
I have one. It's for David, just because I'm also an apparel designer, technical designer, and fit creator. So I tend to work with all of the body measurements and the patterns. I'm guessing the workflow that you're having is more or less that you're working on the tech packs, getting the images or the patterns from the pattern team to then implement in 3D and then pushing it back out, right?
Yes. So I work with a factory in Pakistan, and there's been some inaccuracies depending on the garment that we're trying to make, and it could be very much, I take a pattern that's to spec, and then I can drop it on my frame or any measurements that I want to plug in, and then double check it so that if they come back to me and they say we're not sure this is going to work, I can say with confidence it will.
Yeah. Well, so the big thing that in apparel that I've seen is obviously when we design off, it really gets into the design cycle process and where it starts and how it starts, right? But if I'm working with a factory, I oftentimes find that if I'm pulling in a rig that I've used from something else or an avatar that is not consistent through the design cycle process, that it does in fact fail, especially under men's tailored goods. Much more of the high fashion tailored garments tend to fail because of stature and stance being such a key factor in wovens versus knits. So I don't know if that's something that you've ever seen, but I know it's something that really like honed, skilled pattern drafters are seeing, which is why we invented a new rig for that system, because we found that it was also failing in 3 centers of gravity and aging protocols.
It sounds like with the clothing's too light, right? The material is too fine. It doesn't behave well under gravity.
No,
No?
it literally does not work. If, let's say, for example, we use a rig system that doesn't have the correct posture of the target market category. So let's say it's a 45-year-old male clothing division that makes fine suits, right? We
Okay.
get the fabric physics just fine because we run it through a physics test that the 3D RC rolled out. And we make sure that those tests are in kind with each other, right? Then we begin the build out. If we do the build out on the avatar in program, and then we push it out to do the sample, it's too shallow in the shoulder. It doesn't fit the pitch of the neck. It doesn't fit those things because the posture value of the neck and the collar shoulder arc is wrong.
Just consistently, it's just wrong.
Yeah.
Huh.
Which is why we had to make a new rig system structure that allows for that, because it doesn't equate to actual garments. And we were able to track like about a 7% increase in return rates just alone off brands that had onboarded 3D within the last 3 years.
So I'm not going to lie to you. I did for digitizing patterns to basically the workflow that we are developing is new to me. I'm used to sending tech packs. I'm not used to building out in 3D and going through the process. That's something that we want to do. And so this to me is very much sort of like a thing that we now need to be aware of when Rich and I kind of continue down the next step, because if we run into that roadblock, now we know that there may be one.
Yeah, that and that's where like we have in the IEEE standards. Right now, we're building a standard of due diligence because also the EU law system and the FTC now are rolling out due diligence laws on engineering tools within computational backgrounds. So if a product or an item is made for reality, any digital tool that interacts with that factor needs to be vetted across that back end, because a lot of avatars in the market were not vetted for that and they're utilized, and then it creates a fit inconsistency or issue depending on the level of that brand, or even 3D mobile body scan apps that are delivering inconsistent shapes across the board because they have their base body that they're matching to. So now the whole system is basically getting some laws applied to it that say, hey, you have to do due diligence in whatever you're producing to interact with reality-driven product.
So we need to get on that forum and get ahead of that. But no, okay, I understand. I see what you're saying. Not to continue down this rabbit hole. Have you heard of the company 3D Look?
Yes, and I've tested their product as basically we did like a big test where we took 4 different mobile body scan apps and we scanned 12 people, same lighting, same distance, same outfits, same color, right? So all of the environmental aspects were the same. and we got 4 different body types out for each and every single one of those, but we did a pattern driven by the body to match it
Okay.
in reality against the person, and majority, so it was 90% fail rate.
Wow. That might be why, because we approached them in conversations about how to generate avatars for what we were doing quickly. And that might be, did you tell them your findings?
Oh yeah, they were there when we found them.
Okay. So I'm wondering
We
if maybe
worked
that,
with their
because
team on those problems for sure.
they showed reluctance in working with us. And
Yeah.
I would be surprised if that wasn't why.
Well, some of that was also related to the due diligence laws that are rolling out. So they're having to kind of like remap some of that, like that value chain, because it's one thing when you're doing like fitness, but if they're seeing a different representation of what their actual body shape is, or even the posture of their body shape, because they also don't fix that, you get, it wipes out all of your fit data, because posture is such a great part of the fit data method that it wipes it all out.
Gotcha. Okay. That's, this, it's amazing how complex all of this is. It's so interesting.
Yeah.
You know,
Okay.
it might be interesting for you to know the company that I built a lot of my cloth engine for was a couple of years back, String King. They mostly make sporting equipment, but they started making a line of sweatshirts and t-shirts and stuff. They're not really known in the apparel industry. They had something like a 90% success rate in matching their digital assets to the customer and like almost 0 returns. But their philosophy behind it was like their digital garments would have 200,000 triangles, and the time to fit the pattern onto the avatar was something like 20 to 30 hours grinding on a computer. They were a little bit heavier on the math and precision, but it all worked really well.
Oh yeah, I mean, it can be done with the right thing, but case in point is if you take your like you stand or sit more straight up, but then you roll your shoulder forward, right, and you kind of bend your back forward, it extends all of those measurements out. And then and most people actually do hunch over like that because of their phones and devices and sitting at a desk, rather than standing like super erect or straight up like many of the platforms would have. And so if you are making a shirt, right, and I have that structure, the measurement that I apply to the back across shoulder and on the high point shoulder back to hem becomes shorter in both areas. And so when somebody goes to don that garment and their natural posture is more forward and not back, it feels tight, and the gravity pushes on the front shoulder and you end up with issue. And so for tailored goods, the aspect of accuracy becomes like 2 millimeters depending on the point of measure section. So if it's like the collar, that's like a 2 millimeter differential between sizes, and so 2 to 3. So it's got to fit that spec and track some of that motion for some of the aging process, because we see that's, again, most companies that even make dress forms, it's for everybody under the age of 35. And unfortunately, we live well beyond that. And aging people have commented that they can't find appropriate clothes to fit them through that process, whether it's a suit jacket or whatnot. So they end up going, like men will go to a tailor to get that done, but women are different creatures when they consume clothing. So that's just something that we have seen, and why in the IEEE 3D body standards we've really pushed to have various rig systems, we have different quality outlines for fidelity and some of the motion work, as it will ultimately relate back to the clothing.
We when I was at Gerber, we had a lot of tools for analyzing things like the stretch in certain areas. And,
Yeah.
So
Well,
displaying as weights,
that's gotten way better. Like I would say honestly, like the material science end has really been pushed, especially under SETI, which does the AI work, and then Shimashaki that does the render yarn by yarn work. So those two companies kind of combined forces with Adobe and started pushing a whole lot of the science and research. So they have about 32 PhDs on that whole ball of wax. So it's gotten really, really much better than it was even a year ago in terms of fabric physics. But it's dealing with the tailored versus the athletic, because those are two just very different markets, and the way the physics of the fabric behave, and even the way we do it in reality, where we pattern draft for knit versus woven, is different. So we actually pattern draft have different methods for the knit world versus the woven world, because they are physically so different mathematically, and from a weight perspective, like you have to.
Primarily it's just they're a lot stiffer, which means that the fit has to be a lot more accurate.
Yeah. But that was more of like a development question for David, was, that pathway. And then, because I see this as a great tool for marketing, and you don't have to necessarily be as accurate when you're marketing something as you do when you're like making a pattern to sell and bet for testing,
Absolutely.
All right.
Can I ask you a quick question? So I'm from VRM Consortium, and VRM is for avatar format for metaverses or video games or like real-time use cases. So I think both of the tools you showed us today, both the animation and the clothing, is going to be a game changer for the lots of artists who are more likely to be an individual or small companies that creates those metaverse of real-time content. And so what I was wondering is, like, who is what is your plan? Like, who is your target audiences for these plugins? Are they for individuals, or are they for like big companies? What do you have in your mind?
What I have is, the first market that I'm reaching out to is the small companies and individuals who do this as a hobby. And building inside a Blender seemed like a really good start, because that community is very forgiving and likes to give feedback. So yeah, my initial target is definitely just like individuals. And so I tried to make the tools really easy to use. In spite of that, I'm finding that it's more advanced animators who really get it and are able to pick it up and use it. Kind of a secondary market, I was really hoping to find some game studios that I could partner with that could maybe steer the course of the development and also get it some financial backing. So I'm kind of starting with just the average hobbyist or small studio, and hoping to make connections with some bigger people, and maybe offer it as like a SaaS product where they could request features or something like that. So.
I see. Amazing. Yeah, thanks for answering that.
Yeah, and any other questions? Joe, do you have any questions for the speakers? See, you have unmuted. If you're talking, we are not able to hear you.
No, I was going to say, I mean, I look at this and I fantasize about it. I come from 3D printing.
Joe. I'm with the Web3D Consortium, and did I interrupt? I'm sorry.
Oh, no, you're good. No, please jump in. I've been talking
Okay.
enough.
Is this, the end goal is a standards track. And for example, is this gonna, you think it's gonna develop into the idea where we will have this kind of simplified, or however I can say it, sort of physics skeleton, that the physics runs the skeleton and then the skeleton runs the avatar skeleton, kind of like, is that kind of a required kind of structure on that, or is it possible just to hook up the physics? And I'm thinking of rigid body type physics in the system. If I can share a screen real quick, I just wanted to show, I think it's this one right here, where, for instance, this is our set of nodes that we use in our rigid body physics component. And are you using a kind of a standard physics package, or do you have to hook them together in a kind of proprietary way, or is, we've had some physics hooked up with our HN that worked pretty good, but I didn't see the kind of auxiliary physics skeleton in that system, and so I'm just trying to look ahead a little bit and see see how we can hook it up. It's kind of a collection of, if you can see, it's just a collection of nodes in our rigid body physics section, section 37 in the X3D thing. Do those look familiar, or just asking about the basic style of putting it together first, and then the nodes that we need to actuate the thing.
Well, in all of the videos that you saw, there was only a single skeleton that was moving the character meshes and being moved by the physics setup. So it's, but like I built avatars for the apparel industry, where every muscle has to move correctly, and for that you put in a whole lot of extra bones. And there's not necessarily like a universal way to know if a bone is like a base part of the skeleton, or if it's a bone that like adjusts some soft portion of the character, or controls the movement of some other part of the character. So just because of that, you can't just like take an existing rig with all of these complexities and click go with the physics. You have to build something similar, but you can certainly do it the way that like all the ones in the video were done, where I built the whole rig with both the physics and the character deformation in mind. And so I've just got a single rig that's doing everything. And that's kind of the ideal way to do it. And then if you, I guess, part of the reason for this discussion is that as I get feedback, the tool itself will evolve and I'll change things. But one way that would maybe make this a lot simpler is if you could go through and just select the base bones, and the bones that would represent sort of like the skeleton, and isolate them from all of the extra control bones that aren't really needed for doing the the base motion. They're just bones that are sort of moving as slaves to larger control bones or whatever. But basically, I'm saying a system where you could go and maybe just select the bones that you want the physics to run on, and just run them on that, and then just ignore everything else. So, like right now, that's not built into the tool, but it would be fairly easy to build that into the tool, for example. So
It would be cool just to differentiate it, call it like a soft bone, like it's not a skeletal bone,
or
but it's
just
an
an ignore
something
bone.
else. Yeah.
Just
Yeah.
you'd have a list of bones that you would ignore, and ones that you would use, and right now it just automatically detects like what's the parent bone for this, and it sets up the physics relationship between those two bones based on parent-child relationships. But if you could do that manually, maybe there's a way to visualize the parent structure so that you could have a different parent-child relationship in the rig than what the physics is basically computing. And then, as part of your earlier question / comment, the physics behind modeling cloth and the character physics engine thing, it's all done in NumPy currently, and it's just like I'm tracking all the velocity and everything, and then I created my own solvers for the character physics to be able to handle the relative matrix transforms of, like where there's two bones, such that the collisions and linear velocity and all that sort of stuff could be transmitted through the relationships between two connected 3D matrices. And I couldn't find an existing physics solution for doing some of those things, so I just built the whole thing from scratch with Python. So it's all just my own baby. There's no bullet or anything in there.
Amazing.
How do you see this being interoperable kind of through the pipeline of things? Because I know that the design pipeline for CGI is it has a whole different set of mathematical variables that you're calculating into something versus that of VR chat. So there's obviously both the cosmetic and then what is happening under the hood to make everything kind of come close is also happening. So is there an interoperability approach that you're planning into that cycle so that if I am wanting to hold the same animation workflow from, let's say, the CGI all the way through to VR chat, is that being tested against the rig structure?
And just a quick note, we are currently out of time, so maybe this would be the last question. And we can still continue the conversation. We'll stop the recording and continue the conversation in a water cooler for 10-15 minutes. So folks can continue and step back. Yeah, go ahead.
So you were asking about the character rig stuff, right? Not the garment related stuff.
Well, so what I've seen, especially like if I'm trying to create some stability around the clothing and the animation cycle, right? And I want it to interact with obviously a CGI level character, which has way more vertices and faces, and weight information connected to it. And then I want it to also work in VR. So the fidelity slightly changes as I go into VR, but also the fidelity of that person in relation to the mesh and the bone count has to change, because like if I'm doing high detail and I want a stretch factor to behave a certain way in CGI, it's different than when I'm taking a larger face and applying it to that same level detail rig, right? On the subdivision, that kind of changes the stretch and the shaping, and it gets a little weird and wonky. So is there like an interchange that you're putting in there for, I think, somebody to go from that interchange, because that's kind of where fashion likes to go. They sit right between the two, ends of detail that you find in CGI and VR. So they want to put their garments into movies, and they also want to put their garments into a VR chat game sequence or mobile device. So is there a method that you're approaching to maybe handle that, or even thought about that?
I mean, obviously, I think about this a lot. the biggest puzzle in all of simulating of garments is the compute problem. Because if you want realistic garments, it's kind of like this previous company where they said, oh, we'll just buy $1 million server farm and we'll let everything run for days at a time, and we don't care about the speed. That's one solution. But that, obviously that doesn't allow you to take a garment and run it in real time in VR. And like, I don't think that there is an answer. I don't think there is a way to seamlessly have the high resolution garment that looks great in a CGI for a movie and also can directly drop into the VR environment and run in real time rendering graphics and stuff. Unreal Engine 4 is getting better at some of those kinds of, Unreal Engine 5 is doing a lot of that stuff pretty well. But even then, like when you have time to do the compute versus having to run in real time, you always have just more flexibility. When it comes to the character physics stuff, separate from the apparel stuff, you're dealing with 300 bones or something, maybe at the most. And so running in real time is trivial, as opposed to 200,000 triangles that have to compute. So the interoperability, you make an asset with character physics for doing a video game, and it's gonna work just as well in CGI, because you're just dealing with a much smaller number of things that you have to compute. So there's not the same issues with the animation system.
Okay.
All right. Thank you, everyone. Great questions. So let's, there's few admin stuff I'll just quickly go over and we'll end this recorded session.